organic reactions are basically classified in three different types, one can say. The first classification is the reaction that are going to called as a polar reactions. One is called as a polar. Second type of reactions, that is non-polar reaction. And the third one, which is basically called as about pericyclic reaction. It is a third important category where we can classify this reaction on the basis of what their nature, example polar, non-polar, etc., etc. Now, pericyclic reaction is something is a different type of a reaction, one can say. And today we'll discuss the major portion from the pericyclic reactions. So before proceeding to the pericyclic reaction, so we must know about what are the characteristic features of that pericyclic reaction. Okay. Usually, pericyclic reactions are basically the molecular reactions having a specific characteristic features. So first of all, the first characteristic feature of that particular pericyclic reactions, the reaction is going to proceed via a cyclic transition state. Via cyclic transition state. This is the very important characteristic feature of the pericyclic reaction. So here the heading is characteristics of PCR, that means the pericyclic reaction. The first characteristic property is proceed via cyclic transition state. It is not talking about, or we are not going to discuss about, or we are not talking about the intermediate. The cyclic transition state is nothing but this is what reactant, it's going to convert into the some specific cyclic intermediate, and then finally you get the product. So that cyclic transition state is the feature of pericyclic reaction. Pericycle, that pericycle meaning is, peri means what, and cycle. Okay, around the cycle, throughout the cycle, through the cycle. That means the transformation, or it is a molecular reaction in which reactant is going to convert into the product via the cyclic transition state. So that is very important. This is the first property of one can say the pericyclic reaction. Okay, we'll move to the next one. So when the reactant is going to convert into the product, before that there is a transition state is there. That is the electrons, or that means electron cloud is moving around the circle. So here this is the electron cloud. Say example, this is the electron cloud which is moving around the circle. Another important feature of a pericyclic reaction, electron cloud is moving, one can say, moving of electron cloud around the circle, around the circle. Another important feature of pericyclic reaction. The third one, this reaction is proceed. You know that there are three types of bond cleavages are there. So there are what? Three types of what one can say the bond features are there. We can call the fission. One is called as homolytic. You know that homolytic. Homolytic. Second is heterolytic. The third important, that is called as a concerted. These are the three types of what breaking which is going to take place in generally organic molecules now. Homolytic means you know that a breaking of covalent bond in a similar fashion. That is the development of the radicals is the Okay, like this one. Heterolysis means nothing but the what? Unequal distribution. Likewise, this one. Either moving the atom. Now, what is concerted? Concerted, those type of what reaction where in a single step on a same there is a breaking is going to take place now, or one can call it bond breaking and making is going to take place in a single step now. Okay, so basically concerted is nothing but bond breaking and the bond making is going to be takes place single step now. So that type of the feature, that type of the process is called as a concerted mechanism. And pericyclic reactions are generally the reactions where it will proceed via the concerted mechanism. The third important property of pericyclic reaction is a concerted mechanism. Okay, these are the three important of one can say the pericyclic reaction. Now, the breaking and that making process of any chemical reaction is explained in two ways. Example, that is called as a synchronous, and one is called as a non-synchronous. Have you heard this name, synchronous and non-synchronous?
No, sir.
So, what is that synchronous? Basically, these synchronous and non-synchronous are related to the concerted mechanism. And what is concerted mechanism now? That means breaking as well as making in a same state. That is called concerted. Now, synchronous are nothing but the making as well as breaking of the bond in a same rate. Rate, that means the same rate is there. You know the rate. Basically, the rate is the term which is obtained from chemical kinetics. The rate of breaking reaction and the rate of making reaction, when similar, that type of what mechanism is going to be the synchronous concerted mechanism. And what is non-synchronous concerted mechanism? Where the making and breaking reaction rate of what breaking as well as the making one are different. So that is different rate of making and the breaking. So that phenomena is going to called as a non-synchronous. So what are the important feature of what pericyclic reactions now? The pericyclic reactions are, first of all, proceed via what? Cyclic transition state.
Cyclic transition state.
Without intermediate, okay? So up till now we learned the intermediate. That means reactant, after that there is a intermediate and then product. Here there is no formation of any kind of what intermediate. Directly the reactant is converts into the product transition state. That's why cyclic transition state. So that's why through the cycle. The meaning of through the cycle is nothing but the pericycle. Through the cycle. The transformation of reactant to the product via the cycle, it is going to called as a pericycle. Okay, and you know that whenever a molecule is going to convert, it is going to convert the product via the moving of electron around the circle. Third important feature is a concerted mechanism, and there are again two types of what mechanisms are there: synchronous and non-synchronous. Okay, the pericyclic reactions are concerted. They may be synchronous, they may be non-synchronous, but it is a concerted one. This is the third feature of what pericyclic reaction. Now the fourth one, generally organic reactions are suppose polar reactions are nothing but the with the help of what polar solvent, right? Example, acid, bases, etc., etc. Non-polars are nothing but the with the help of non-polar solvent. But the pericyclic reactions are characterized by these reactions are induced by either heat or either light. Now, this is very important. Now. That means you have a reactant, okay, and you are adding some HCl, some NaOH, and etc. That reactions cannot be belongs to the pericyclic one. Pericyclic reactions are the reactions which are only influenced, or that reactions are only be induced by either the thermal energy or either what the photochemical energy. So basically, pericyclic reactions are induced by the thermal condition, either what the photochemical condition. There are various reactions in the nature also. You know the vitamin D. Okay, vitamin D, then photosynthesis. There are many examples are the general example. But in that, the synthesis of vitamin D is a light reaction. You know that synthesis of what vitamin is a light reaction. In the absence of light, we cannot synthesize vitamin D. That's why you also know that as a human beings, generally what they need the vitamin D now, and only the single source of what vitamin D is basically what you know that sun, right?
Sun.
Yes,
Yes,
sir.
sir.
Sun rays.
That's why we must influenced by light now. If there is no light, there will be no development or there will be no synthesizing of or the synthesis process of vitamin D now. So example, very simple example. Before that, it is a ergastrol. Ergastrol. So basically, it is a cholesterol now, which is present on our body. When that ergastrol is reacts or treated with the light now, then there is a synthesis of vitamin D3 now. So this is a simple reaction now. If there is a light, then only the vitamin D3 is developed, neither not. So there are various reactions are there, and that's why pericyclic reactions are a very important feature is induced by heat as well as by the light. One more important feature of pericyclic reactions are these reactions are not multi-step reactions. In organic reaction, you know that there are various multi-step reactions are there, but concerted is nothing but the reactant is going to directly convert into the product without any other step. That's why it is a single step reaction. So pericyclic reactions are called as a single step reactions. Okay, in a single step, reactants is going to convert into the product. Okay, got it?
Yes, sir.
Yes,
Now,
sir.
one more feature of pericyclic reactions are these reactions are influenced by either thermal condition or either photochemical condition. If pericyclic reactions is influenced or induced by, induced means what? Startup. Without that, we cannot start the reaction. If any reactant is treated with the heat, that reaction is going to be called as a thermal reaction. That reaction is going to be called as a thermal induced reaction. Okay, or we can call it as a thermal pericyclic reaction. When this reactant is induced by, it converts into the product, no doubt. And that reaction is going to be called as a photochemical pericyclic reaction. Photochemical pericyclic reaction or photochemical induced reaction. So first feature is cyclic transition state. Second one, the electron cloud is moving around the circle. Third one, it is a concerted one. It must be induced by either heat or either light. No base, no acid, nothing is there. That means reactant and you either heat or either thermal condition. It is single step mechanism, so no need to learn multi-step like that. And the important one is a thermal and photochemical. Okay, later on we have next condition for this one. There is no formation of any charged material, or there is that means no intermediate is going to develop. No intermediate. Okay. Now intermediates are in the form of neutral species, in the form of cationic, in the form of anionic, in the form of radic. No intermediate means nothing is there now. Radically reactant is converts into the product. That's it. Okay. Next one. The rate of what pericyclic reactions are unaffected by catalyst. A rate of pericyclic reactions. Rate of PCR, that is pericyclic reactions, are unaffected by the catalyst. Okay, that means there is no rule of what catalyst now here. Generally, you know that in organic chemistry, if we supply the catalyst to any reactant, the reaction is going to be proceed very fast. You know that catalyzed reaction and uncatalyzed reaction. Catalyst is very important, but pericyclic reactions are unaffected due to the catalyst now. So there is no rule of any catalyst here. Only light and thermal condition should be there. Next to that, these reactions have high stereochemistry. That means these reactions are highly, one can say, the stereospecific. This is very important again. That means we can easily define the stereochemistry of reactant as well as the product. So stereospecifically or stereochemically, or we can call stereochemically, they are very important. Next one. If example, in a reactant charge is given, then what about the charge now particular? So whenever a reactant having the charge, that charge must be retained in the product. So if okay, so what about this? Now the next one, if a charge species is in a reactant, then it retain in the product. It retain in a product. Now remember this point. Example, I will give the example to you. Say example here, this is what somewhere charge is given. Okay, and reaction is going to take place in a specific manner. Example here, this bond and this pi bond is going to develop now. This cation should be appear in the product now. That means if any positive or negative or whatever charge is given or present in a reactant, that should be retained in the product. This is the rule number, or this is the feature of pericyclic reaction. Okay.
Yes, sir.
Now we will just back to summarize that point. Now these are the features of our pericyclic reaction. Now we will discuss these all features by using some specific examples. Now what are the examples now? So first of all, you should know what is the stereospecific condition. Now you know that stereospecific means what? Look at this one. So suppose I have the reactant is given. Reactant is like this one. Look at this molecule now. You must have that knowledge to differentiate these two types of the double bond, whether they are same or different. And here I am going to attach the two hydrogen. And now can you give the name to that particular compound?
Hexadiene.
No, it is not only hexadiene. So there should be some stereochemistry, because you know the EZ domain now, right? So you can give the number from any one side. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is what? 6. Okay, it is an hexadiene. It is what? Now we have 6 carbon. That means it is a hex. Okay. 2 and 4 position. We have the double bond and 4. So basically hex 2, 4 diene. It is a name, but the stereochemistry of the double bond should be mentioned. It's very important. So then we can call the name is, now the stereochemistry, whether it is a E or Z, these are called as a stereo descriptor. We already learned in the nomenclature. So this is what hydrogen here, and this is what hydrogen here.
Say.
Now whether it is a E or Z,
Sir, E.
so both the double bonds are E. Okay, that's why it is a 2E comma 4E, 2E comma 4E hexa hexadiene. So this is the IUPAC name of that particular compound now, given compound. Now when this compound is going to be treated with the two different conditions. Example, first of all, this molecule is induced by the thermal condition, and in the second category, the photochemical condition. Now what is mean by stereospecific reaction? At thermal conditions, the product is different. At photochemical conditions, product is what the different. Now look at this, the position of what methyl groups now here. Now look at the product is given. This is what the bond is going to be takes place, and here is the product now. Okay, reaction is very simple. We will discuss the mechanism and all this thing, but now at this condition, just what is just we'll discuss about the condition now. Here the light and thermal and light conditions are given to you now. So this double bond is migrate here, and this double bond is going to shift here now. And here I am going to develop a new pi bond at here now, and new sigma bond is here. So this is newly formed sigma bond, and one pi bond is developed now here. Now what about the position of what the methyl group now here? In first case, the methyl groups are in a transposition, and in the second condition, the two methyl groups are in a cis position. Now these reactions are going to be called as a stereospecific. That means at thermal condition you will only obtain the trans, and in chemical conditions we will obtain the cis. Now that type of the reaction is that the reactions are going to be called as a stereospecific reaction. A particular reactant is going to give the particular product. Okay, so it just depend upon the your light condition, light or thermal, whatever you are condition going to be used now. That means the products which are obtained particularly from light and thermal condition, both are different. Always both have different stereochemistry, one can say. Okay, so this compound is called as a 1,2-dimethyl cyclobutadiene trans. Okay, this is a trans, and here this is called as a cis one. If we do the what back reaction, that means pericyclic reactions are reversible also. One point should be mentioned here: these reactions are reversible. What is that reversible now? Reversible is nothing but the here from this to this one, cycloaddition is going to take place now. And when we are back to this one, this is called as a ring opening. So ring closing and ring opening. So these two are the one can say the example regarding to this the pericyclic reaction. Okay, so have you get the idea about have you got the idea about that PCR?
Yes, sir.
Yes, sir.
Okay. Now in some previous point we just discuss about the cyclic transition state now. So here the example, this is my reactant, which is in a reversible position, and it gives the first of all the cyclic transition state, and then later on the product is given to you. So majority of the pericyclic reactions are nothing but they are reversible in fashion. And if we make the energy profile diagram particular to that reaction, so this is what the reactant, and here it going to converts into the product. Now, this is product, this is my reactant, and this is the cyclic transition state. So most of the reactions are what nothing but a reversible reaction. Okay.
Okay, sir. Yes, sir.
Yes,
Now
sir.
we'll take very simple example. Suppose I have dimerization of ethylene now. All of you know that what is dimerization. So I have two unsaturated molecule. One is ethylene, another is also what ethylene. When these two molecules are combined together in the presence of what a specific condition like either thermal condition or either what the light condition, what happened to that? In generally pericyclic reaction, the reactions are occurred at termini of pi bond. What is the termini now? This is called as a termini. That is the end of the double bond. But generally, pericyclic reactions are occurred at the termini of pi bond. Look at this one now. So this termini, this end of the pi bond is going to make a bond with this one, and this is make a bond with this one. Okay. No need of catalyst, no need of acid, no need of base, etc. Now in the first step, what happened? So this is my previously two sigma bonds, and here I am going to develop a partial bond between the two olefinic molecules. Now this is called as a cyclic transition state, and this cyclic transition state is going to convert into the your stable product, and your stable product is this one. Now look at the product here. Previously, it is a 2 pi bond containing molecule, 2 pi bond containing molecule, and here it is a 0 pi bond containing molecule. Okay, here two new sigma bonds are developed now. Two sigma bonds are, so number of pi bond broken is equal to 2. So here there is simple formula, number of pi bond broken is equal to
Number of
number
sigma
of
bond.
sigma bonds are going to develop. So very simple. So this is what newly formed sigma bond, and this is also newly formed sigma. Now these reactions are called as a cycloaddition reaction. Cycloadditions are nothing but the addition of two unsaturated partner, two or one. It may be one, it may be two now. And there is a formation of cyclic product now. Addition is going to here now. Double bond is going to convert into a single bond. So addition reaction is there, and along with the addition reaction, there is a cyclic product is going to develop. That's why there is a called as a cyclo. So cyclo is the one of the example of pericyclic reaction. We can also consider the one more example of butadiene. You can take the butadiene here. Now I just told you that the reaction is generally going to occur at where it is going to occur now at the termini of pi bond.
Pi bond.
Your two pi bonds should be mutually
Termin.
or spatially
Terminal.
oriented. This is an example of cis butadiene. And if I going to use the trans one, then it's very difficult to example this one. So this is called schizoid and transoid double bond. Schizoid are nothing but the where termini are very closely arranged, or they are mutually arranged. In case of a transoid molecule, both the termini are very far from each other. It's very difficult to make a bond, make a transition state. So that's reaction. There is a one condition: the reactants double bond should be very closely arranged. Sometime what happen now? Example, suppose I have closely arranged double bond, but the methyl groups are there. Now this molecule is again very difficult to participate in the reaction. Why? Because of there is a crowding of two methyl group is going to take place. Along with that cis, okay, no doubt these are the cis-wide double bond. Here the termini of the pi bonds are closely arranged or they are spatially oriented, but because of that methyl groups are present very close to each other, so due to the steric hindrance, it's very difficult to make a bond. Similarly, I have the example is this one now. Look at this molecule and look at this molecule. Here methyl groups are far from each other. So this molecule is participated easily, but this is not. Similarly, trans cannot be participated in this one, but cis can be easily participated. Okay, so this point should be keep in mind first. Okay, let's take the example of the same molecule, that is butadiene. Here, what happened to the butadiene? It is now it is a ring closing mechanism. Here, look at this one. So this will be going to be shift here. This will be going to be shift here. So it developed four-membered cyclic transition state. Look at this. Okay, now here. Now what happened now? This is going to be formed. This is called four-membered cyclic transition state. Here, this is a newly formed sigma bond, and this is a pi bond. Now total number of pi bond,
1.
two pi bonds
Either
are there in a reactant,
and 1
and
new
now
product.
here number of pi bonds are 1, and here now one pi bond is going to break now here. So from reactant to product, one pi bond is reduced. So one sigma bond is going to add. So here the sigma bond is, one can say, is equal to 1. And here this is a newly formed sigma bond. Okay.
Yes.
Okay, sir.
So this is in case of what pericyclic reaction, very interesting part. The very interesting part is there. So you must remember all the key features of pericyclic reaction. First of all, in whole topic, the stereochemistry is involved now. You must know the electronic configuration. You must have some knowledge of general organic chemistry, because all the points are already covered in some previous topic. Okay.
Yes, sir.
Yes, sir.
Okay. So let's move on to the next part. That's the types of a pericyclic reaction. So very simple again. And you know that the founder of a pericyclic reactions are Dennis Elder. You know that. Okay. Dice and Elders are two different scientists. Okay. Then Woodward is there. Hoffman is there. There are many people are there. They are actually participated in the pericyclic phenomena. We'll discuss one by one. And I also uploaded some uh, material on our classroom, so you can visit there. You can download that material particularly, right?
Yes, sir.
Yes, sir.
Okay, that's fine. So basically, what pericyclic reactions are nothing but they react to the transition state. Uh, we have the specific classification of pericyclic reactions are, okay, classification. So we'll move to part that is classification of pericyclic reactions. Now, how to classify the pericyclic reaction? It's very again simple one. The classification is based on their principle. Now, first example is electrocyclic reaction. Electrocyclic reactions. Second type of what reactions are called as a cycloaddition reactions. The third type of reactions are sigma tropic reactions. The fourth one is called as a group transfer reactions, and the last one that is called as a Chilotropic reactions. Now these are the 5 broad classification of that particular year.
Pericyclic reaction.
Pericyclic reaction. Okay, so this is the first one, second, third, this is fourth, and last is the fifth one, Chilotropic. Now electrocyclic means what particularly? Then we will take some example related to that. It will be easy to understood. Okay, so electrocyclic reactions are unimolecular reactions. Okay, so molecule is unimolecular, particularly single molecule is also sufficient. Look at this molecule now here. Okay, like this. This is the example of
Electrocyclic reaction.
okay. What happened here now? This bond is going to shift here. This bond is going to shift here now. The reverse step is also called as a electrocyclization, ring closing and ring opening mechanism. So what the main thing is that it is an unimolecular now. Very single molecule is required to make the product. What is cycloaddition now? Cycloaddition reactions are it required single or more than one compound, more than one unsaturated molecule. Example, suppose I have this is a diene and dienophile. Example, this is what diene and this is what dienophile. When I mix that diene and dienophile, so there is a simple chemistry is there now. Look at this one, like this, and here a new molecule is going to be developed, which is a cyclic now. Again, number of pi bond brochures are equivalent to number of sigma bonds are going to form. Look at this one. So cycloaddition reactions, electrocyclic reaction, cycloaddition reaction. The third one is a sigmatropic one. Sigma means sigma bond and tropy means migration. The migration of particular your atom or a molecule along with the sigma bond. So one of the best example is co-prearrangement. You know that co-prearrangement is the best example. This is a molecule which is called as a 1,5-hexadiene, and 1,5-hexadiene is going to convert into this one. How it going to proceed now? This bond is going to form here. This will be shift here, and this will be shift here via cyclic transition state. Okay, the important is via cyclic transition state. The next one is group transfer now. Group transfer mechanism is best example is so that hydrogen is going to called as allylic hydrogen. Allylic hydrogen is going to transfer onto the double bond, and here this type of the mechanism is going to proceed. Now this is called as a group transfer mechanism. Here like this, and the newly formed sigma bond is here. And the last one, that's called the chilotropic reaction. The chilotropics are nothing but a single reactant simultaneously make a 2 sigma bond. Example, you know that Simon-Smith reaction, addition of carbene. Look at this addition of carbene, addition of nitrine. All of the examples are belong to this one. Look at this one now. These are the pair of electron on carbon. So simultaneous there is a formation of how many sigma bond?
Cyclotropic. Two.
Two sigma. That is single reactant is
Hmm.
going to develop two sigma bond.
Cyclotropic.
That mechanism is going to called as a chilotropic addition. Reverse step is called as a chilotropic elimination.
Hmm.
Now, pericyclic reactions are reversible. Majority of the reactions are, we already told that the reactions are reversible. So, in each and every reaction, the something is different. These reactions are induced by either thermal condition or either physical condition. They are highly stereospecific now. But in each and every reaction, there is something is different. Electrocyclic reactions are unimolecular. Cycloaddition reaction means there is a formation of only cyclic molecules. It may be intra or it may be inter, within the molecule or between the molecule. Okay.
Yes, sir.
Yes, sir.
तो अभी आपको थोड़ा डिफिकल्ट लग रहा होगा इतना सारा एक साथ कैसे याद रखना है.
मजा आ रहा है सर.
नहीं सर, इतना डिफिकल्ट नहीं लग रहा.
Okay, let's move on to the first one, that is called electrocyclic reaction. Now we will discuss first one. What is that electrocyclization? This is called electrocyclic reactions. And each and every reaction have its unique feature. That's why don't be confused with that. Okay. Each and every reaction
Yes,
have
sir.
its unique feature now. That's why no need to confuse.
Yes, sir.
So what is meant by electrocyclic reaction? Electrocyclic reactions, first of all, these are unimolecular reactions. Unimolecular. Okay, that means only single molecule is responsible for this. The condition of what molecule should be, which type of molecule is needed now? The unimolecular, and molecule should be conjugated. Molecule should be, this is very important. Only conjugated single molecule is responsible. And what is conjugation now? You know that what is conjugation? I simply mention the conjugated molecules are in the form of like this one. Suppose I have the like this. This is called conjugated molecule. You got it that what I mentioned here? Your whole molecule is conjugated now. Open molecule. Let's take the example. The first example for that is a butadiene. Next example is next example is hexatriene. Another example is, you can take this example like this. This is one double bond, another double bond. Okay, another, and another. Look at this. These are highly conjugated molecules. Okay, got it?
सर वो ऊपर वाला फर्स्ट नंबर वाला नहीं समझा सकती थी. वो ऊपर वाला पाई
This
बॉन्ड.
is the whole pi molecule now. Whole pi bonds are there now. This is the pi bond. It may be 1, it may be 0. It may be 1, it may be 0, it may be 2, it may be 3. Suppose I have the molecule with this. I have the molecule with this one. I have these two double bonds are mentioned here. These are the two double bonds. Now here pi bond is 0. Internal pi bond is 1, 0. If I put the pi bond is 1, then what will happen now? My structure will be this one. Here internal pi bond is 1. This is called internal pi bond. If internal pi bonds are 2 now, then what will be the structure now?
ये next वाला.
The two pi bond which are exist at the termini, and these are the two pi bonds. This is called as the pi is equal to 2 now. Yes or no?
Yes, sir.
Yes, sir.
Okay. So now, first of all, the requirement for that electrocyclic reactions are a molecule should be conjugated, and the molecule is unimolecule. Okay, the single
Yes, sir.
molecule is going to be participated in the reaction. Now, every molecule have the conjugation. The reaction is only occurred at the termini of pi bond. This is very important. Reaction is going to take place on the termini of pi bond. These are nothing but the termini of pi bond. What is the termini of pi bond now? Look at the product of this reaction. Okay, this is the reaction, and here this is my pi bond, and here, okay, here this is a, okay, this is what?
New sigma.
Sigma.
Sigma bond. New.
It may be thermal condition, it may be
Photochemical.
photochemical. So the second point is reactions are occurred at the
Termini of pi bond.
termini of the pi bond. Termini of what? Conjugated molecule, one can say. Okay, so here we can simply call reactions are occurred at termini of pi bond. Now let's look at the example now. Example is what? I just use that specific molecule. This is my conjugated molecule here. First of all, and it is reversible. Okay, if it is reversible, the electron cloud should be moved around the what? Around a circle like this one.
Around.
We'll get the intermediate like this fashion. Sorry, transition state like this fashion, and finally you will get the product is here. This is the final product, and here this is what? Newly formed sigma. Now forward reactions are called as a electrocyclic ring closing, and backward reactions are called as a electrocyclic
Ring opening.
ring opening. Okay, and where is the termini of pi bond?
नीचे वाला.
This is nothing but the termini of pi bond. Okay,
Yes, sir.
so how can you define the electrocyclic reaction? The electrocyclic reactions are nothing but the formation of a new sigma bond at the termini of conjugated pi system.
Conjugated bond.
Okay, so here definition is formation of new sigma bond at
Termini of conjugated pi system.
conjugated pi system. Okay, that phenomena is called as a
Electrocyclic reaction.
Now let's take the example. A very simple example is we have the diene now, and again it should be a cis because reaction occurred at the termini of pi bond. So both the double bond should be spatially oriented. This is a, okay. This should be a cis now. What happened in the first step now? The first step is going to take place like this fashion, and here you will get the cyclic transition state. This is the key feature of pericyclic reaction. Now, how many electrons are involved in this reaction?
4 electrons, 2 pi bond.
These are the 2 pi bond system. That is, it is a 4 pi electrons cyclic transition states. And finally, that will going to develop the bond here. This is the newly formed sigma bond. This is what? New. Now here total number of pi bonds are 2 in a reactant, and in a product only 1 is remain now. That means 1 pi bond is broken, so 1 pi bond is should be developed. So this is the chemistry must be remembered. Okay.
Okay, sir.
So that means 1 pi bond is going to convert into the 1 sigma bond. So here 1 pi bond is going to convert into the
1 sigma bond.
1 sigma bond. And again, the second difference is the position of pi bond is also going to change now. Position of pi bond also changes. Now this is about the this is about the butadiene now. We can also consider the one more again one thing is there now. If this is the double bond, this is the such type of the molecule is given to you now, and we are applying the either thermal or photochemical conditions, so there is a no reaction being developed. So this is why
दूर है सर ते
ट्रांस की वजह से
so these are the termini of pi bonds are not mutually oriented. Okay, and if they are not mutually oriented, so there will be no reaction. So very simple thing. So because reaction is occurred at the termini of pi bond, electrocyclization is nothing but the at the termini, and on the termini, if two are mutually oriented, then it will be formed. Neither not. So that's why pi system or the pi bond at the termini, they should be in a special contact. One can say mutually oriented. Now these reactions are further classified. Electrocyclization reactions are classified. Look at another reaction. Suppose I have the molecule is 135 hexatriene. 135 hexatriene is a cyclic is a molecule where conjugation is there now, and here all the 3 pi bonds are going to be participated like this fashion. So total number of pi bonds are involved. There are 3. That means it is a 6 pi electron. And finally, you will get the product. Now look at the product. Number of pi bonds are developed now here. How many pi bonds are there remain, and how many sigma bonds are newly formed? Here newly formed sigma bond is only 1, and these are the 2 pi bonds. Position of pi bond is also changes, and the one newly one can say the sigma bond is going to form. Okay, so basically this is a 6 pi electron system, and in previous reaction it is a 4 pi. So electrocyclic reactions, are going to be classified. Electrocyclic reactions are going to be classified on the basis of the number of pi electrons are involved in the cyclic transition state. Classified on the basis of number of pi electrons involved in what? Cyclic transition state. And there are only 2 types of what cyclic transition states are there. One is called as a 4n pi, or we can call it as a 4 pi, and this is called as a
6 pi.
So 4n pi or 4 pi electron, and 6 pi means 4n plus 2. We can call it as a 4n plus 2 now. Like you can also be mentioned here. So there is a simple rule is there to remember all these things. If in a reactant even number of pi bonds are there now, 4n pi electrons are generally identified on the basis of 4n pi electron system or 4n pi electron electrocyclic reactions are those reactions where even number of pi bond involved. Okay, the reaction in which even number of pi bonds are going to involve. Even number means either 2 pi bond, 4 pi bond,
2,
6
4,
pi
6.
bond,
Even
etc.
numbers.
It's not the electron, it is a number of pi bond. Then
Pi
you can
bond.
easily classify whether it is a 4n or 4n plus 2. Now what is 6 pi now? 6 pi means odd number of pi bond involved. Odd number of pi bonds are involved. That means what? It is standard. So this is a classification of electrocyclic reaction now. It's classified on the basis of cyclic transition state now, number of electrons. So there are only two types of what cyclic transition state. One is here, I'm going to explain you, and second is here. Look at the two transition state we have. Okay, this is what. Okay, got it? Okay. The formation of transition state.
Okay.
Look at this. This is the transition state is going to develop, and charge should be retained. So here, look at the pi electron. Okay. So here, like this, and this is the charge. And finally, the product of this reaction is the cation is going to rearrange, and here
यहाँ
the
पर हो जाएगा सर वो 2 मिथिल यहाँ पर
newly sigma bond is here now, and here is the positive charge. Now charge should be, if charge is given in the reactant, it should be retained in the product. So it is only one pi electron, one pi bond means it is a one pi bond. One pi bond means
2 pi electron.
two electrons, and
हाँ
two
सर 2
electrons are which category? Look at this one, odd number of pi bond. Odd number of pi bond, basically it is a one pi bond is involved here. So two electrons are going to be here, and two electrons are example of 4n plus 2 system. Okay. So one pi bond is here. One pi bond means nothing but the two electron. And two electron is basically an example of
4n plus 2.
Have you heard the aromatic compound? Aromatic compounds are nothing but those having 4n plus 2. And 4n plus 2, the best example is 2 electron also. 2, 6, 10, etc. Like that. Okay, anyway, look at the next example. Here charge is given now.
Okay. हाँ.
Again, the reaction should be occurred at the terminal of pi bond. Now, how reaction is going to take place now? This pi bond is going to be transferred here. Okay. This is basically it is a negative charge, not the positive. We will take the negative example. Okay, like so. This will be going to be transferred here. This will be going to transfer here, and this will be going to shift here. So, how many electrons are involved here?
6.
They are 6. And what kind of the reaction is this? This electron means, look at this one. This is the transition state is given to going to form, and negative charge should be at the center. This is a 6 pi electron system. And finally, what will be the product now?
Sir.
Huh? Is it visible? Okay, fine. So this is what a newly sigma bond is going to be developed at here now. And you know that the pi bonds are at here. So only one pi bond is here and negative charge is here. This is a product of the particular reaction. And the last reaction is given to you now. This is the termini of pi bond. This will going to be shift here. This will be going to be shift here. So you will get this is what the cyclic 4-member transition. Why? Because it is a 4-member. Because only 2 pi bonds are involved, and if 2 pi bonds are involved, it belongs to 4n pi electron system. Okay.
Yes, sir.
And this is the product of. Now the one important part is remaining, that is stereochemistry. We will discuss stereochemistry later. We will discuss the stereochemistry later. Okay, this is the problem. Look at this. So this is what pi bond, and this is what the sigma
bond.
Okay, so these are the very important reactions regarding the electrocyclization. Okay, I will give some example to you. Just solve this example. Try to find out the exact product of this reaction. Must. Okay, this is what a molecule is given to you, and find out the product of this reaction. Okay, and the one more big example.
सिर्फ हम करेंगे ना सॉल्व ये
Yes.
ओके ओके नहीं हमें लगा कि आप आंसर लिख रहे हैं क्या नेक्स्ट पे
No. Okay, and the number of pi bonds are here. This is 1, this is 2, this is 3, this is what 4, 5, 6, 7, and 8. Okay, so these are the 3 very simple problem regarding the without stereochemistry. Okay, no, there is no involvement of stereochemistry. So just go through that study material which I provided.
Yes, sir.
Okay, and remaining things will be discussed in the next lecture. Okay, so we will discuss next to the cycloaddition reaction, and after that all 5 reactions we will back to the stereochemistry of that reaction. Okay.
Okay.